like you to do is I'd like you to have a 60-second conversation in your pod about everything you know about inverse functions. When I say inverse functions, what do you think of? 1, 2, 3, go. All right. Pod 4, tell me something you discussed.
When we think of inverse, we think of like the inverse function or if it's inverted.
Okay, an inverted function. Good. Pod 6, what did you talk about? We're replacing the x's with the y's. Pod 3. Ooh, when you plug the inverse function into the original function, you get x. Very good. Pod 2, anything else that you talked about? Anything unique that you guys talked about?
Not like unique, just a 1 over a function.
Okay. I like how Pod 6 was describing it. That is what we're going to focus on in the inverses that we work with today. Okay, everything that you guys said was awesome. What we're going to focus on today is the replacing x's with y's. Okay, and we're going to do that with function notation. I'm not sure if you did this notation last year. Do you remember this notation? So you have seen it before. Okay, so this is f inverse, f to that -1. Okay. Basically what's happening is we have x's and we have y's, which is like our f of x, right? And for our inverses, they switch. So if we have a domain and range for f, they switch for the inverse. So the domain of f is the same thing as the range for the inverse. The range of f is the same thing as the domain of the inverse. Okay, so I'm going to give you a graph. Number 1, is this a function? Yes, it is a function. Excellent. So, Pod 6 said, switch the x's and the y's. Okay, so if we have a graph and we want to find its inverse, we're going to switch the x's and the y's. Does anybody remember the special relationship a function has with its inverse graphically? It's like perpendicular. Okay, I like that. We'll come back to that.
It's reflected across the line f of x equals x.
Okay, it is reflected along the line f of x equals x, or y equals x, which makes it have that perpendicular effect. Okay, so I'll come back to that line. Let's go ahead and take this graph and find its inverse. So on our graph, we have the coordinates 0, 0. If we switch x and y, what do we get? Oh, that was kind of boring. Here's another boring one. This is the coordinate 1, 1. When we switch x and y, we get... Let's make it a little more exciting. This is the coordinate -1, 1. When we switch x and y, we get the coordinate -1, -1. Here's the coordinate 2, 4. So on the inverse, we have the coordinate 4, 2. And then, of course, 4, negative 2. Okay? So here is our inverse graph. Okay? Jen said it looks perpendicular, kind of has that effect. If we draw in the line that Jackson was talking about, we have that reflection about the line y equals x, or f of x equals x, however you want to write it. Okay? Now, does anybody have an issue with that red graph? Darby, what's your issue? It is not a function. Okay? So technically, y equals x squared doesn't have an inverse in its entirety because the inverse wouldn't be considered a function. Okay? So I want to tell you about, I'm going to come back to this because y equals x squared, well, it doesn't have an inverse in its entirety. We can adjust it so we can have an inverse, and I'll show you what I mean here in a little bit. But I want to talk about something that is called the horizontal line test. Okay, so we have something called the vertical line test. Now we have something called the horizontal line test. Turn to your neighbor and make a guess as to what the horizontal line test is going to help us establish. All right. Anybody have an idea that they're willing to share? Go for it.
Draw a horizontal line at any point on the graph and it doesn't cross the y.
Okay. So, not Kelsey. Because you're Kelsey. It does start with an A. Amanda. Okay. Amanda said if we draw a horizontal line and it crosses more than once, then our inverse isn't going to be a function. Okay, do you see that? So if our horizontal line hits more than once, that means when we find the inverse, it's not going to be a function. Okay, so our horizontal line test, similar to the vertical line test, tests whether or not our function has an inverse. So if it passes the horizontal line test, that means when we find the inverse, it will be a function. I guess I should probably put an if there. Test if function. You guys notice how bright our board is today with that new bulb? It's fantastic, isn't it? Okay. If a function passes the vertical line test and passes the horizontal line test, we call that a one-to-one function. Because not only do we have one input for every output, but we also have one output for every input. It's passing the horizontal and vertical line test. So one input for one output and vice versa. Okay? Who can give me an example of a function that is one-to-one? Y equals x cubed. What's another one?
Linear?
Any linear function that's not a vertical line. Anything else? Yes, the identity function, which is linear, right? Square root function, does it pass vertical and horizontal line tests? It does. It does. So let's talk about that square root function. Okay, so over here, y equals x squared does not pass the horizontal line test, therefore an inverse doesn't exist. Okay, if we want an inverse to exist, we would have to restrict the domain. If we have y equals x squared, but only when x is greater than or equal to 0, then an inverse can exist. But it can't exist in its entirety. Okay? Also, if I give you a square root function, if we find the inverse of a square root function, what is it going to look like? Only half a parabola. Okay, it's not going to be the full parabola, it's only going to be half the parabola. So those are some things we're going to need to think about while we're doing the algebra of finding inverses. Okay? Which I think we're gonna go out of order here. I'm gonna start with this example. We are going to find inverses. Now, luckily, you guys have worked with inverses before. You've told me that in order to find an inverse, we need to take the x's and y's, we need to switch them. Okay? So I'm not going to make a list of steps that you need to follow because you've done this before. So we're going to do a couple examples, and what's going to be important about the examples we do is the domain and range. Okay? So what I'd like you to do, I'd like you to think of the parent function and its transformation, and as a pod, determine what the domain and range are for this f of x. You don't have to graph it, but think about the graph. All right, so I hope you are visualizing this in your head. A square root that's been shifted. You're visualizing this in your head. Sorry. It's been shifted to the left. Correct? Okay. Sarah, what's our domain? Good. Including -2 to infinity. We start at -2, we get bigger. Kelsey, what is our range?
Bracket 0, infinity.
We begin at y equals 0 and we get bigger. Okay? So now let's focus on our inverse. It is not a requirement for you to graph, but it's good for you to think about the graph so you can think about the domain and range. So now let's focus on the inverse. The first thing I do is I change f of x to y so that then you can go ahead and switch x and y. Okay? Now we need to solve for y. What's our first step in solving for y? Gabe? Square both sides to get rid of that radical. X squared equals y plus 2. So y is x squared minus 2. This is how I'd like you to notate. We're finding the inverse. So with function notation, f inverse is x squared minus 2. All right. The domain of the original function is negative 2 to infinity. What does that tell us about our inverse? That the range is negative 2 to infinity. The range of our original function was 0 to infinity, which means the inverse has a domain of 0 to infinity. Whatever your domain and range are for your original, you switch them for x and y. Okay? Now, x squared minus 2. That doesn't usually have a domain of 0 to infinity. Doesn't that usually have a domain of all real numbers? So why is it 0 to infinity? Okay. Why is it half? What do we start with? We started with the square root, right? So when we reflect a square root about that line y equals x, we're going to get only half of the parabola. Okay? It is important for you to think about the domain and range of the original function. That way, when you get to the domain and range of your inverse, you know that they're just going to be switched. Okay? You're going to have to be careful when you have the square root and the quadratic inverse relationship, because an entire parabola cannot have an inverse. It has to be restricted. Okay? Questions on this example? Almost lunchtime. Still have a couple more minutes. So what I'd like you to do is I'd like you to write down this example. I will tell you right now that the examples that we do today, the one we just completed, and this one will be very, very important examples for you to be able to do. They may come up later. I would like you in your pod to identify the domain of this graph, which means I should hear some talking. All right, pod 5. Can you tell me what you decided on for your domain?
Negative infinity to 2 bracket.
Bracket?
Yeah.
And is that it? Okay, so can you tell me how you came up with that?
Because it makes sense in my head. But I don't know how to describe it.
Where'd you come up with the 2?
Because x cannot be 2.
Why?
Because it would be on the line.
If you plug in 2, what is your denominator?
Negative 2.
Negative 2, okay. So I like where you're going with the negative 2. We can't plug in negative 2, but can we plug in values above negative 2?
Yes.
Can we plug in values below negative 2? Yes. So instead of writing it like this, Will, I want you to write it as negative infinity to negative 2 and negative 2 to infinity. But we're going to use parentheses because we do not want to include negative 2. When we come back from lunch, I want you to think of maybe what the range is going to be. What do we have to think about for the range? Enjoy your lunch. We will be back. All right. So now, okay, we can do a couple different things with this problem. We can think about the range of this function right now. Or we can wait till we get to the inverse and think about the domain. Okay. Now, I think that we can think about the range of this function just fine. Can anybody tell me what we have to consider when we talk about the range of this function? Okay, here, let me ask a question before that one. What's happening at x equals negative 2? Graphically. There could be an undefined line. What do we call that? It's an asymptote. Okay. Now we will come back to that whole situation, Caroline, at the end of chapter 2. Okay. Because there could be a hole or there could be an asymptote. Right now you really only know about. I mean, you guys just know what holes are, but you didn't really graph it last year, correct? Yes. No. Okay. So at x equals negative 2, there is a vertical asymptote, which is why we don't have any domain there. If there's a vertical asymptote, what else is there? What? There's a vertical asymptote, and there is a horizontal asymptote. Okay? So, if we wanted to identify the range right now, we would have to remember where that horizontal asymptote would be, so we could exclude that from our range. Okay? How do we figure out where horizontal asymptotes are? We don't have to do the inverse to figure it out, but that could, we'll eventually figure it out when we get the inverse. You are right. How can we tell from the equation? Does anybody remember? The numerator will give us zeros. Okay? All right, so let's do this. Let's go ahead and find the inverse, and we'll come back to that conversation. Okay? Because what are we most concerned about right now? Finding the inverse. Okay? Make sure you copy down this problem. Okay? So first thing we're going to do is we're going to replace y with f of x with y. And then we are going to switch x and y. So all of our x's become y's and vice versa. We can write and talk at the same time. All right, we need to solve for y. What's the issue? There's first of all, it's a fraction. It's not a terrible thing, but there's more than one y. It kind of makes us panic. Okay? If there is more than one y, we need to group them together so that we can force there to only be one y. So first of all, fractions, let's just get rid of it. How do we make that to where it's not a fraction anymore? Multiply that y plus 2 over. Okay? Now, since we have more than one y, we want to group them together. Okay? So before we can group anything together, we'll need to distribute this x through. So we have xy plus 2x equals y minus 3. Okay. So now, let's put y's on one side and non-y's on the other side. Okay? So xy, I'm going to leave that over here. I'm going to subtract this y over here. And then I'm gonna subtract the 2x to the right side and leave the negative 3. Now, what can we do with the left side? We can factor out a y. So now it looks like there is only one y, okay, which is why we did that. Okay, we put all the y's on one side, that way we can factor the y out, and now we only have one to solve for. Okay, so what's our last step? Divide over that x minus 1. Oops. Okay, so then in function notation, I would want to see f inverse of x is negative 2x minus 3 over x minus 1. Okay, so now we need to talk about the domain and range of the inverse, and we need to come back to the range of the original function. Okay, now, anytime you have a rational function, its inverse is also going to be rational. So they should, your answers won't look the same, but they're going to have similar features. Okay, turn to your neighbor and decide on the domain of the inverse. All right, Finn, tell us what you think.
Parenthesis, negative infinity, comma 1, parenthesis, with, comma 1, or parenthesis 1, comma infinity.
Great. Essentially everything except 1. Do you agree with Finn? Say we can't divide by 0. We have a vertical asymptote at x equals 1. So it has to be excluded from our domain. Okay? So let's come up to our original function. If the domain of the inverse is everything except 1, what does that mean about our original function? That's the range. And if the domain of our original is everything but negative 2, then the range for our inverse is everything except negative 2. So let's go back up to the original. Before we found the inverse, how would we maybe know that our range was everything except 1? We can know. There is a way. Okay, I will remind you about, excuse me, horizontal asymptotes. Okay, anytime we have a rational function, okay, especially this simple, with these simple rational functions, we've already talked about a vertical asymptote, there's going to be a horizontal asymptote, and then you might have something that looks like this, right? Okay, so when we talk about the range, we need to figure out where that horizontal asymptote is and exclude those numbers. If you recall back in Algebra 2, if the degree of your numerator was the same as the degree of your denominator, then your horizontal asymptote is whatever those coefficients are. So here we have an asymptote at y equals 1, which correlates to our range. Here, in our inverse, since the degrees are the same, we have a horizontal asymptote at y equals negative 2, which is why negative 2 is excluded in our range. Okay? Now, we're going to work with rational functions more in Chapter 2. So here would be my advice to you. When you have a rational function where you're supposed to identify the domain and range, find the inverse and find its domain and range, it is very straightforward how to find the domain of a rational function. Do you agree? Figure out where that denominator is 0. We've been practicing that for a week now. If you can figure out the domain of the original, and then you find the inverse and figure out the domain of the inverse, then you can fill in the ranges based on your domain, because they're going to switch. Does that make sense? So if you don't want to worry about the horizontal asymptotes, you can like push that back out of your mind until next week or 2 weeks from now. Okay? You can do these problems with just thinking about the domain of the original, domain of the inverse, and then filling in the ranges if you'd like. Okay? So we have about 15 minutes left of class, which I would like you to use to work on your homework. Okay? I want to get some questions answered during class. That way you don't have very much homework to take home tonight. And so tomorrow, we can spend as much time as we can on teaching aerobics.
This is my complete list.
That is not a problem.